Mr. Hissner here. Today I'm going to look at using the inverse normal function on your calculator for these problems that we have right here in front of us. So first thing we're going to do is look at what this is asking us. It says the length of human pregnancies from conception to birth varies according to the distribution approximately normal, with the mean being 266 days and a standard deviation of 16 days. So I just went up ahead and sketched this up here. So this is what we're looking at here. Approximately normal, mean of 266, standard deviation of 16, so maybe like about here. The distance from the mean to the first standard deviation would be 16. And we want to know how long is the longest 10% of pregnancies. So the longest 10%, that means that if we're considering all the pregnancies here, right, if this would be 100% of pregnancies, we want the longest 10%. So that means that if we were to consider the area under this curve, how many of these are accounted for, it would be approximately 90%, right? So that's what the longest 10% is. If it was the shortest 10%, we would consider it to be over this way, for example, but for this problem, we want the longest 10%, so I'm going to mark it there. Now, how can we use this to find what we want? This is approximately normal, so we want a z-score. Now, my calculator is at TI-84 here, but if you're using the 83, it'll be about the same. So what you want to do is you want to go to your distributions, so second vars, to get to your distributions menu, and then use this inverse normal function. And it's asking me things here. I believe, okay, since this is the z-score, since that means that our we want a z-score, so we're going to use 0 and 1 here, and this is to the left. I think if you have a TI-83, it won't matter, and I'll show you that in 1 second. So, but the TI-84, it's prompting us how much area is to the left. That means that, like I showed you before, we want this piece. This is the 90% that we're looking for. It's to the left here. And as I said in class, that's how you always want to think about these, because that is the convention. What's nice, though, is that this would let us do to the right. I will not encourage that. But all right, let's go down here, because this is what you want. If you're using the TI-83, I think all you need is to press inverse normal, parenthesis will open, just put 0.9 and close the parenthesis, and it should give you this value. And I'm just going to see if this will let me do that here. If I close all of these and I delete this comma, yep, yeah. So that's actually all you need. These other pieces are assuming that, it's just kind of flexing that it can do a lot of other stuff. It doesn't matter, though, because what we want is the inverse normal. And this gives us the z value. So that means that this has a z-score of 1.8. So this has a z-score of 1.28. And we want to know how long did they last. So I know what the z-score is. I want to know some value and then use our formula here. So all I'm going to do is I'm going to say, okay, well, that means the z-score is 1.28. I don't know how many days there are. I know that the mean is 266. And I know this has a standard deviation of 16. So multiply both sides by 16, add 266. So this is going to look like 2.8 times 16 plus 266. And that is x. And that's how we would get our answer for this first one. And the other ones are similar. So hopefully this will be enough of a guide to get you guys going and looking at the other ones. Thanks for watching.